Hello my dear students. Today we are going to start with a very interesting topic, that is eigenvalues of a matrix. So if we are having some square matrix A, then eigenvalues are nothing but the roots of the characteristic equation of a matrix A. Now we have already studied what is characteristic equation of a matrix A, that is nothing but determinant of xi minus A is equal to 0. So we have already seen that it is a monic polynomial of degree n. So if you find the roots of that polynomial, then they are nothing but what? The eigenvalues. They are sometimes also called as the characteristic roots. Now the question is, how many eigenvalues or how many characteristic roots will our matrix A have? So it depends on the order of the matrix. If your order of the matrix is n, then it is going to have n eigenvalues. Now see, it will have obviously n eigenvalues, but out of them some may be repeated. Okay, so it may happen that your eigenvalues have 1 1 1 as eigenvalue if your order of the matrix is 3. This may happen, but you will say that these are 3 eigenvalues, right? This is not only one, because your characteristic equation in that case is going to be x minus 1 whole cube is equal to 0. So this 1 will be repeated 3 times, but yes, you can say that it has only one distinct eigenvalue, that you can say. So whenever you are having a matrix of order n, then that matrix is going to have n eigenvalues, may be repeated, may be distinct. So depending upon this, let us see few problems. So from practical number 2, we'll go for first question. So in this particular example, we are supposed to show that 5 is a characteristic root of A. So without any delay, let us start. So we have characteristic equation of A as, we have characteristic equation of A as determinant of xi minus A is equal to 0. Now I have already told you the shortcut. What will be this determinant? It will be determinant of x minus 2 minus 1 minus 2. Simply multiply by minus sign to the entire matrix, and diagonally you are going to add x. So it is going to be minus 3. This is going to be only x because the diagonal element is 0. This is going to be minus 2. This will be plus 1 now. This will be minus 2, and this is going to be x minus 4, which is equal to 0. Now chalo, let us solve this determinant. So therefore it will be x minus 2 determinant of x minus 2 and x minus 4. Now it will be plus 1 determinant of, it will be minus 3 minus 2 1 and x minus 4 minus 2 determinant of, it will be minus 3 x 1 and minus 2, which is equal to 0. Therefore x minus 2, now what will be the determinant? X multiplied by x minus 4, this will be minus 4, right, plus 1, this will be minus 3 multiplied by x minus 4, this is going to be plus 2, this will be minus 2, inside the bracket 6 minus x will be equal to 0. Now let us solve it further. One thing I would like to tell you, now see, in the second year I guess we have learned synthetic division, so that will be required here. So if you are not able to recall it, I suggest you that you go through the first year notebook where we have learned the synthetic division method. So this will be x minus 2, inside the bracket this will be x square minus 4x minus 4 plus 1, inside the bracket it will be minus 3x plus 12 plus 2 minus 12 I guess, and it will be plus 2x, which is equal to 0. And therefore now again take the product, it will be x cube minus 4x square minus 4x minus 2x square plus 8x, and it will be plus 8. This will be minus 3x plus 12 plus 2 minus 12 plus 2x is equal to 0. So this requires a little bit practice. So after practice you will be able to do these calculations very easily. So there is going to be only one term of x cube, so I will write it as it is. Now let us see how many terms of x square are there. 1, 2. So minus 4x square minus 2x square will be minus 6x square. So it will be x cube minus 6x square. Now let us check the terms of x. So 1, 2, 3 and 4 terms of x are there. So 8x minus 4x will be 4x. So 4x minus 3x will be x, and x plus 2x will be 3x. So over here you are going to get plus 3x. Now what about the constant term? So over here you are having 1, over here, so 12 plus 2 will be 14, and 14 minus 12 will be 2, and 8 plus 2 will be 10. So this is plus 10 is equal to 0. Is required is characteristic equation of A. Now let us find the roots of this characteristic equation. So the possible rational roots will be, so the possible, I am using rational root theorem over here, the possible rational roots of let me call it as some star are, so the divisors of 10, right? So plus or minus 1, plus or minus 2, plus or minus 5 and plus or minus 10. So one by one we will check. So first of all we will go for x is equal to 1. So for x is equal to 1, what we are getting, 1 minus 6 plus 3 plus 10, we should get 0, right? So then it will be a root, but over here I think we are getting 1 minus 6 is minus 5, 3 minus 5 is minus 2, and 10 minus 2 will be 8, so which is non-zero. So therefore you can say x is equal to 1 is not a root, is not a root of star. So we'll go for what? Minus 1. So for x is equal to minus 1, what we will get? Minus 1, minus 6, minus 3 plus 10. So is it 0? I think yes. So therefore I will say x is equal to minus 1 is a root of star. So we got one eigenvalue, right? That is minus 1. But we have to show 5 is eigenvalue of what? A. So now we are going to use what? The synthetic division. So I will say by synthetic division. So how to use it? Since we already know one root, that is minus 1, let us write down the coefficients of the characteristic polynomial, that is minus 1, minus 6, 3 and 10. So this 1 as it is, so 1 multiplied by minus 1 is minus 1, so it is minus 7, minus 7 multiplied by minus 1 is 7, so 7 plus 3 is 10, and 10 multiplied by minus 1 is minus 10, and remember you should get 0 over here. So if you do not get 0, it means we have made some mistake in order to check that x is equal to minus 1 is a root. Therefore star can be written as, so how can you write it? Now note, since minus 1 is a root, what will be a factor of star? It will be x plus 1, right? So when minus 1 is a root, the factor is x plus 1. If 1 is a root, then factor will be x minus 1 in this way. So therefore you will have x plus 1. We have already written that. star can be written as, so no need of therefore. So it can be written as x plus 1 over here x square minus 7x plus 10 which is equal to 0. This implies x plus 1 is equal to 0, or x square minus 7x plus 10 is equal to 0. So this will imply x is equal to minus 1, or what are the factors in this case? So multiplication should be 10, right? And the addition should be minus 7. So can you find such numbers? I hope minus 5 and minus 2 should work. So therefore over here you will have x minus 5 multiplied by x minus 2 is equal to 0, and this will imply x is equal to minus 1, or x is equal to 5, or x is equal to 2, and that is what we wanted to prove actually. So therefore I'll say the eigenvalues of A are minus 1, 5 and 2, and therefore I'll say 5 is characteristic root of A, right? That is what we wanted to show. 5 is characteristic root of A. So that's all for today's class. So in the next class we are going to discuss one very important theorem, that is Cayley-Hamilton theorem, and after that Cayley-Hamilton theorem we will see some more problems. So we'll stop here. Thank you.